For Hagerstown and Martinsburg tomorrow.
Weather forecasters use them to create the nightly weather report. Airline pilots use them to learn how to fly planes. Experts use them in virtually every industry and discipline. They're computer models. At NASA, scientists use computer models to enhance our understanding of the Earth, the solar system, and the universe. NASA satellites orbiting the Earth relay immense amounts of data back to scientists on the ground, who can then enter that data into computer model simulations.
We have then equations, and then we have computer code which solves those equations on a day-to-day basis.
NASA is the source for most of the research satellite observations of the atmosphere, land, and oceans.
So the NASA scientists will look at the observational data and make theoretical projections of what a model might look like, and they will build a numerical model based on the data and then run that on our computers and then compare that to reality.
With rapid increases in computer technology, models are becoming ever more powerful and sophisticated, allowing us to simulate our complex environment in greater detail. NASA uses a variety of weather models, such as the Goddard Earth Observing System model, or GEOS-5. It creates an extraordinarily high-resolution, realistic-looking view of our atmosphere. These GEOS-5 simulations showcase the model's ability to capture fine-scale cloud features worldwide, like the swirling clouds in the Atlantic Ocean off the coast of North America. The goal of weather models is to give the most accurate prediction of weather over the next week to 10 days. In 2005, when Hurricane Katrina formed over the Atlantic Ocean, scientists wanted to understand the storm. How intense was it? What was its size and structure? And what would be its final path? NASA satellites continuously monitored many aspects of the storm, from wind speed, rainfall, and sea surface temperature, to the storm's three-dimensional structure. To get a more complete picture of the storm and predict its evolution, scientists entered the data into a computer model. Then, high-powered supercomputers, capable of trillions of calculations per second, crunch the numbers. This process is called data assimilation. Data assimilation is a two-step cycle that repeats itself whenever new data becomes available. In the first step, the model runs forward in time to provide an estimate of the atmosphere. In the second step, this estimate gets corrected using observations. Then the cycle begins again, each step building upon the last and accumulating the information from satellite and ground observations. Weather models are updated every 6 hours to include the most current observations for the next forecast. This approach prevents the model from straying too far from reality and acts as a checks and balance system to achieve the most accurate forecast. While weather models predict conditions for up to 10 days, climate models predict trends over much longer periods of time.
The climate models that are run at the NCCS are numerical expressions of the various processes that make up the climate. This includes things like land surface, movement of water in the ocean, and the movement of air in the atmosphere.
Just as in weather prediction, data assimilation is a way of bringing all the observations of the Earth together to provide an analysis of our climate. One example of this technique is MERA, the Modern Era Retrospective Analysis for Research and Application. MERA incorporates data from the entire satellite record, over 30 years of data. Its results are a data encyclopedia that can be used for research and analysis. MERA can help meteorologists understand the variations associated with specific weather events in the past. While MERA gives us a climate picture across decades, the Goddard Institute for Space Studies, or GISS, can extend that view across centuries. GISS models have already unraveled average temperature trends over 200 years. New GISS simulations will cover the last 1,000 years to verify the model's accuracy. They'll also look forward, projecting climate trends to the end of the 21st century. With each satellite launched, we gain millions of measurements that tell us more about our planet. Having so much more data will require increases in computing power to synthesize this information into meaningful representations of the climate system as a whole.
At Goddard Space Flight Center, we have a tremendous amount of observational data which is captured by our satellites. We have probably the largest collection of Earth scientists anywhere in the world, and we have this new state-of-the-art computing center. So the combination of the scientists, the data, and the computing puts us in a unique position to enable advances in weather and climate research.